Okay, so this is lesson 5.1 or 5-1, solving systems of linear equations by graphing. So before we get to the graphing, we first have to look at systems of linear equations. So it just says, well, it's a set of two or more equations with the same variable. So all this means they have one ordered pair that's a solution. So we start out by just checking that. So this first example, it'll make sense once we try one. It says, tell whether the ordered pair is a solution of the system of linear equations. So the point is 2, 5, and they give us two equations. So we just plug those in. Plug 2 in for x, plug 5 in for y. 2 plus 5 equals 7, so it works for that one. So then on this one, 2 times 2 is 4, minus 3 times 5 is 15. So 4 minus 15 is negative 11. So since it worked for both of those, it's a solution of the linear system. Okay. Example 2, negative 2 is 0, and they're plugging it into these two equations. So they plug 0 in for y. Negative 2 times 2 is positive 4. 4 minus 4 is 0. That works. Then on the second one, negative 2 plus 4 does not equal 0. That equals 2. So what you would say is it's a solution of the first equation, but not of the second. So technically, it's not a solution of the linear system. Okay, so let's go ahead and try a couple of these. Try 1 and 2. Tell whether it's a solution of the system of linear equations, or tell me if it's a solution to each individual equation. Okay, on number 1, we have the point 1, negative 2. So we are just plugging it into these to see if it is, to see if we can solve it. So we have the point 1, negative 2. We plug 1 in for x. So we have 2 plus negative 2 equals 0. So that one is true. Negative 1, that's a negative, so when we plug 1 in for x, it stays in there. 2 times negative 2 is negative 4. Negative 1 plus negative 4 is negative 5. That does not equal 5. So only that one is a solution. So then on number 2, when I plug these in, Three plus 1 is 4, so that one is a solution. Negative 1 plus 5 is also 4, so those are both solutions. All right, let's look at the next example. Okay, now we're going to look at solving a system of linear equations by graphing. So this first example says solve these by graphing, and they just give us two equations. So we graph them. Okay, that's the easy part. You just graph them, but do them on the same graph. So we look at your slope and y-intercept. So on this first one, my slope is negative 2, which means negative 2 over 1. And my y-intercept is 5. So we would go to 5 on the y-axis and put a point. Then my slope is negative 2, which means I go down 2 over 1. And I normally go ahead and graph a few of the points, so then you can see where to draw your line. So we drew that one. So then you do the second equation. So my slope is 4, which means 4 over 1. Y-intercept is negative 1. So you go to negative 1 on the y-axis. There's a point. Slope is 4 over 1. So it means you go up 4 over 1. And then you would draw your line. So how you find the solution is the point where they intersect. They both crossed at the point 1, 3. So that means on this problem, our solution is 1, 3. Okay, it says we can check it on our calculator. If you would like to, you can. You just have to go to the y equals at the top left. On the first line, type one of these, go down to the second line, type the other one, and click you can click graph or trace, and you can hit the over arrow until it is right there where they intersect. Okay, so hold on one second. Let me erase these points. I'm going to have you try some of these. You're going to solve the system of linear equations by graphing. Let's just do 3 and 5. Don't worry about number 4, just 3 and 5, and then I will go over them with you. On 3 and 4, we're actually solving by graphing. So on 3, these are ready to go. Our slope on this first one is 1. Y-intercept is -2. So I go to -2 on the y-axis and put a point. My slope is +1. So that means 1 over 1. So I go up 1 over 1. Up 1 over 1. I'm just doing several. Okay, and you might have to continue it to find out exactly what point is your solution. The other way, down 1, left 1. Okay, so there's that line. So then the other one, y equals -x plus 4. So that means my y-intercept is 4. I go up to 4, put a point. My slope is -1. So -1 over 1, which means I go down 1, left 1. So they cross right here. That is 1, 2, 3, 1. So our solution is 3, 1. Okay, on number 5, same thing, but now you have some extra steps first. We have to first solve for y, get them in slope-intercept form. So I subtract 2x to the other side. So that one is y equals -2x plus 5. My slope is -2, y-intercept is 5, so I'm going to go ahead and graph it. I go up to 5, put a point. My slope is -2, so that means down 2 over 1. Okay, the other one, I'm going to subtract 3x. And then I have to divide everything by -2. Negative into negative is positive, so I'm going to leave that 3 over 2x. Positive 4 divided by -2 is -2, so -2. So I go to -2 on the y-axis. There's my y-intercept. My slope is positive 3 over 2, so that means I go up 3 over 2. And they intersect at the point 2, 1. That is your solution. Okay, another example. This one's the real life model. So it says a roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. In a second purchase at the same price, the contractor buys 8 bundles of shingles for $256. Find the price per bundle of shingles and the price per roll of roofing paper. So we're having to find 2 things. So that's our x and y. So the hardest part is setting up your equations on this. So we know 30 bundles of shingles and 4 rolls of roofing paper. And these are all talking about prices. So I'm going to say bundles of shingles can be x, rolls can be y. So that would be 30x plus 4y is going to equal 1,040. Okay. Well, then on the second one, we can say this because they're the same price. 8 bundles, so 8x equals 256. They didn't buy any rolls of roofing paper on the second purchase. So those are your 2 equations right down here. 30x plus 4y equals 1,040. 8x equals 256. So we can graph those. First thing we have to do is rearrange them to y equals. These are harder to graph because they are such large numbers. So on their graph, they counted by 40s on the y and by 4s on the x. And if you notice, where they intersect is between 2 things, but right at 32. So they said it appears to be at 32.20. We don't know exactly. So they just kind of picked where they thought it was. So then you can plug it back in to check like we did at the very beginning, example 1. The point 32.20. Plug 32 in for x, 20 in for y. And when we do that, we get exactly 1,040. And then on this one, when we plug 32 in for x, we get exactly 256. So that means the point 32.20 is the exact point. So that means 32 is x. The price per bundle of shingles is $32 each. And the price per roll of roofing paper is $20 each. Okay, now I know that's not super simple. Let's look at or read their look back. It says you can use estimation to check that your solution's reasonable, which is what they did here, but then you can plug it in. They said, so a bundle of shingles cost about $30. $30 of shingles and 4 rolls of roofing paper at $20 per roll is about $980, and 8 bundles cost $240. These prices are close to the given value, so this solution seems reasonable. They're just saying, if you had said 30 instead of 32, because again, we don't know exactly what it was in there. We were kind of estimating. Okay, if you are struggling with this one, that's okay. I know this one's harder. You can just watch through till we go over it. But try number 6. It's okay if you don't get it.
You have 6 more math exercises than science exercises. How many exercises do you have in each subject? Because you have a total of 18 math and science exercises, the number of math exercises plus the number of science exercises equals 18. Because you have 6 more math exercises than science exercises, the number of math exercises equals 6 plus the number of science exercises. Let x be the number of science exercises and let y be the number of math exercises. Because the number of math exercises plus the number of science exercises equals 18, equation 1 is y plus x equals 18. Because the number of math exercises equals 6 plus the number of science exercises, equation 2 is y equals 6 plus x. Next, graph each equation. Notice that equation 1 can be written in slope-intercept form as y equals negative x plus 18. Graph y equals negative x plus 18. Notice that equation 2 can be written in slope-intercept form as y equals x plus 6. Graph y equals x plus 6. Notice that only the first quadrant is shown because x and y must be positive. Next, estimate the point of intersection. The graphs appear to intersect at the
Okay, I just want to say the reason he said x and y must be positive is because you're looking at the number of problems that you're doing for homework. You're not ever going to have a negative number of problems. I just wanted to use him working this out because his graph looks much better than mine did.
0.612. Substitute 6 for x and 12 for y in each equation to check the point. Substitute 6 for x and 12 for y in equation 1. 12 plus 6 equals 18. Because 18 equals 18 is a true statement, the ordered pair 6, 12 is a solution of the first equation. Substitute 6 for x and 12 for y in equation 2. 6 plus 6 equals 12. Because 12 equals 12 is a true statement, the ordered pair 6, 12 is a solution of the second equation. Because 6, 12 is a solution of each equation, the solution is 6, 12. So you have 6 exercises in science and 12 exercises in math.